What's going on, guys? Assalamu alaikum. Welcome to Amigoscode. So we're going to carry on the series where I hope to teach you Kubernetes in the right way. It's a really complex topic and a lot of people make it seem really complex, but hopefully I want to make it super simple for you to understand. In this video though, I'm going to teach you about the Kubernetes architecture. If you're new to my channel, go ahead and subscribe. Also give me a thumbs up and comment down below and let me know what you think about Kubernetes, or if there is anything that you want to learn, please do let me know. Without further ado, let's kick off this video. Let's go ahead and learn about Kubernetes. Kubernetes originated from Google, where they've been deploying and working with containers for many years now. And internally they have this tool called Borg. Was a very successful internal system that allowed Google to deploy billions of containers every week. From Borg, then they developed Omega, and from Omega, Kubernetes was born. Now, just to note that Kubernetes is actually written from scratch. So it shares the same DNA of Borg and Omega, and the difference here is that it's open source. So everything that developers at Google have learned over the years developing Borg and Omega, they took all of that knowledge and mistakes along the way and they came up with Kubernetes. So Kubernetes is open source, which means that both you and I can contribute to this awesome project. Fun fact, Kubernetes is actually written in Golang, which is an amazing language. And if you want to learn about Golang, go ahead and check my website where I've got a course on Golang. Now, the easiest way for you to picture Kubernetes is by looking at this picture. So here you can see that we have this cargo, and Kubernetes really, it means pilot. It's a Greek word that means helmsman or pilot. You can see that the ship has a bunch of containers, and then Kubernetes is actually managing all of these containers. Now, if you know about containers and Docker, then this should be somewhat familiar to you. And if you need to learn about Docker and containers, go ahead and check my website where I've got a course waiting for you on Docker. So let's dive a little bit deeper and understand Kubernetes. So Kubernetes, aka K8s, where the 8 is the 8 letters in between K and S, is an application orchestrator. So in this picture, you can see that we have Kubernetes, and Kubernetes orchestrates all of these applications. When we are talking about applications, we mainly refer to containers. So Kubernetes deploys and manages our containers. It also scales up and down according to demand. It performs zero downtime deployments, rollbacks, and much more. So knowing Kubernetes will set you apart from many software engineers, because right now the demand for people that understand Kubernetes is quite high and the salary as well is super high. So knowing Kubernetes will take you a long step in your career. Now, when we talk about Kubernetes, we need to first understand what a cluster is. So a cluster is a set of nodes, where a node can be a VM or a virtual machine, and these can be running on the cloud such as AWS, Azure, or Google Cloud, or even on premises. Now, when we talk about the Kubernetes cluster, we have to understand the difference between the master node and the worker node. So the master node is simply the brains of the cluster. So this is where all of the decisions are made. And then the worker nodes, this is where all the heavy lifting work happens, such as running your applications. And both the master and the worker node, they do communicate to each other via the kubelet, which I'm going to teach you in a second. Now, within a cluster, you often have more than one worker node. And for this particular cluster, we have 4 nodes in total, 1 master node and 3 worker nodes. Now that you know what the Kubernetes cluster consists of, next let me go ahead and dive deep into both the master and worker nodes. Right, so you saw that within the Kubernetes cluster, we do have the master node. Now, the master node contains what is known as the control plane. The control plane is made of several components, and they are the API server, the scheduler, cluster store, controller manager, cloud manager, which talks to the underlying cloud provider API, whether it's AWS, Google Cloud, Azure, so on and so forth. And all of these components within the master node, they communicate via the API server. And also we do have the worker nodes, but these are outside, right? So the master, it's a node, right? So a VM that contains all of these components right here. And then we have the individual worker nodes, which I'm going to explain what they are in a second. So now let's start by understanding what each of these components inside of the master node do. So let's start with the API server. Now the API server is the front end to the Kubernetes control plane. All communications go through the API server. This includes external and internal, and it exposes a RESTful API on port 443. And also, in order for you to talk to the API, authentication and authorization checks are performed. So in essence, we have the API server. If you are talking externally using kubectl client, which you're going to learn later. So here I'm saying kubectl apply and then F for a file. And this is a YAML manifest that I'm going to teach you as well. So this file is actually sent to the API server. And also internal communication goes via the API server. So you can see that this is a very important component. Next, we have the cluster store, where this really contains all of the state for our application. So it stores the configuration and state. And currently Kubernetes uses etcd, which is a distributed key value data store. And etcd is the single source of truth. So it's our database, right? So like any other application that you build, the database contains the source of truth. So here, if I use kubectl or kubectl, which you're going to learn in a second. So if, for example, you want to apply a YAML manifest, then that goes through the API server all the way to the etcd store. So etcd contains the configuration for our entire state. So in here, I'm in the official website for etcd, and you can see that it's a distributed reliable key value store for most critical data and distributed system. You can see that the features, it's simple interface. It has a key value storage. You can see that it stores the data really organized in directories as in the standard file system. And here it watches for changes on specific directories, and it also reacts to changes. And you'll see why this is important in a second. So if I scroll down, you can see that the adapters, so here Kubernetes is the backend for service discovery and stores cluster state and configuration. So this is really important. This is really important. And also you can see that etcd is written in Go, which has excellent cross-platform support, small binaries, and great community behind it. And communication between etcd machines is handled by the Raft consensus algorithm. So you're going to learn about this later in this course, but I just wanted to show you that etcd is really, really nice, and it's been adopted by quite a lot of organizations and projects, and you should be aware and familiar with it. Now, let me go back to the slides and learn about the scheduler. So the scheduler watches for new workloads, pods, and assigns them to a node based on several scheduling factors. Is the node healthy? Does it have enough resources? Is the port available? Affinity and anti-affinity rules, and other important factors. So you can see that it's a really important component. Next, we have the controller manager. So this is a daemon that manages the control loop. So basically, it's a controller of controllers. In Kubernetes, we have a bunch of controllers, And let me just show you the node controller. And what this controller does is whenever the current state doesn't match the desired state, then it reacts to those changes. In our example here, we are setting the desired state equals to 1 node. And this is not the actual way to do it, but this is just an example. And if we have 1 node, then if this node dies, right? So if this node has a problem, maybe it has a disk failure, or it ran out of memory, or any other factor. So if this node dies, then the node controller is responsible for bringing another node. So you see here, so this is the purpose of the node controller. We have other controllers such as the replica set, which is responsible for ensuring that we have the correct number of pods running. We have the endpoint controller, which assigns pods to services, namespace, service accounts, and others. And to put it this way, what the controller manager does, it simply watches the API server for changes. And the goal is to watch for any changes that does not match our desired state. So we have a desired state and we have the current state. If the desire doesn't match the current state, then the appropriate controller kicks in to try and match the desired state. So a controller is simply a watch loop. We also have the Cloud Controller Manager, and the Cloud Controller Manager is responsible to interact with the underlying cloud provider, such as AWS, Azure, or Google Cloud. So in this example here, we have a bit of configuration, and you're going to learn about all of this and what it means. But basically, this configuration right here, or this manifest, I've called ingress.yaml, contains an ingress, and this gives us a load balancer. Now, first, this request goes through the API, and then that gets stored, and then the Cloud Controller Manager kicks in. Now, depending whether you are running Kubernetes on AWS, for example, then it creates the load balancer, which is an ALB, Application Load Balancer. If you're running within Azure, then it creates the equivalent, but using the Azure Cloud API. The same for Google Cloud. So you see that the Cloud Controller Manager is responsible for interacting with the underlying cloud API provider. So you've seen how it does it for load balancers, but it's the same with storage or instances. So these are VMs. And to be honest, these are all of the components for the master node that makes up the control plane. So the master, in a nutshell, runs all clusters control plane services. And as I said before, it's the brains where control and decisions are made. And there we go. You now know about the control plane and master node. Next, let's go ahead and learn about the worker nodes. So you've learned about the control plane and master node. Now let's focus on the worker nodes. So as I said before, the worker nodes, this is where the heavy lifting work happens. So the worker node is a VM or a physical machine often running Linux. It provides the running environment for your applications. So this is our worker node, and inside we have the applications. So right here, so we have a pod, and you're going to learn about pods later, but this is for now, you can think of a pod as a container in the Docker world. And one thing to note here is that when deploying your applications, you should really be deploying microservices. So here we have 3 microservices. So microservices A, B, and C. If you want to deploy monolithic applications, then you should really be considering splitting into small microservices, because this is where Kubernetes does shine. And also, microservices is the standard these days, and this is where the industry is moving. So moving on to worker nodes, the worker node has 3 main components. So if we look into it, so here we have the worker node, And inside of each worker node, we have the kubelet, which is an agent, and you're going to learn in a second what it is. You also have the container runtime. I'm going to explain this in a second as well. And also we have the kube proxy. And remember, I said that the node itself is actually a VM or a physical machine. So in this example, let's say that this is a VM which runs Linux with 4 cores, 32 gig of RAM and 100 gigabytes of SSD storage. So you can see that this node has 3 components: kubelet, container runtime, kube proxy, and it runs on Linux. So let's learn about the kubelet. So the kubelet is the main agent that runs on every single node. It receives pod definitions from the API server. It also interacts with the container runtime to run containers associated with that pod. And it reports node and pod state to the master node through the API. So here you can see that the API talks to the kubelet, and the kubelet also talks back via the same channel. And the kubelet also interacts with the container runtime. So what is this container runtime? Well, the container runtime is responsible for pulling images from container registries such as Docker Hub, GCR, ECR, and ACR. So these are some of the popular ones. But basically, it's responsible for pulling images, starting containers from those images, and also stopping containers. So the main thing here is that it's responsible for running containers, and it abstracts the container management for Kubernetes. And within it, we have the container runtime interface, and this is an interface for third-party container runtimes. So you might have heard that Docker was recently deprecated by Kubernetes, and this is because it's in favor of Containerd, which is becoming now the standard container runtime for Kubernetes. So let me quickly show you. So right here, I'm inside of the Containerd official page, and you can find the link for this website under the description of this video. And you can see that they say it's an industry standard container runtime with an emphasis of simplicity, robustness, and portability. And as of the 28th of February of 2019, Containerd became part of the Cloud Native Computing Foundation, following Kubernetes, Prometheus, and others. So basically, you can see that they explain the ecosystem in here. And right here, you can see that we have the kubelet, and right here we have the container runtime. And here they say that it manages the complete container lifecycle of its host system, from image transfer and storage to container execution and supervision of low-level storage to network attachments and beyond. So I'm going to leave the link for this page right here. You can see the adapters. So IBM Cloud Kubernetes Service, Google Cloud right here, Docker as well, Instana, Firecracker, and others. So go ahead and check this link to learn more about Containerd. If I go back to the slides and move on to the last component within the worker node, which is the kube proxy. So the kube proxy is an agent that runs on every node through a daemon set. And it's responsible for local cluster networking. It makes sure that each node gets its own unique IP address. And it's also responsible for routing network traffic to load balance services. So you're going to learn about all of this in a second. So for example, if 2 pods want to talk to each other, so kube proxy is what's doing the magic. If you as the client wants to send a request to your cluster, kube proxy is responsible for handling all of that. So there you have it. Now you know about the 3 main components within the worker node. And also you've learned about the control plane, which gives you the complete picture of the entire Kubernetes architecture. So knowing all of these components and how they work together will make you understand everything once we start using Kubernetes. If you have any questions, go ahead and drop me a message. Otherwise, let's move on. Right, so you've learned about the Kubernetes architecture. In the next video, what we're going to do is learn how we can have a local Kubernetes cluster running on our local machine. And obviously throughout the next videos, you'll see all of the components that make up the control plane, as well as the components within the worker nodes in action. So you'll see all of that in action. So don't forget to subscribe, give me a thumbs up, let me know what you thought about this video, and I'll catch you in the next one. Assalamu alaikum.